All right, so let's do this problem. All right, here we go. Let's do the problem together, and it is really important as we do the problem, y'all. As we do the problem, think about what's happening in the context of the story. Okay? That's going to become really important as we move on down the list. All right, so what do we have to start with? What was the formula that Danny put together? He used his iPad, and what was the bottom line function that Danny developed for us? The function for what? Position. All right, and that is x of t is equal to t cubed minus 18t squared plus 60t plus 72. All right, let's go. What is A? Find what? V of t and A of t. Can we do that? What is V of t? 3t squared minus 36t plus 60, correct? Don't let me mess up. What is A of t? 6t minus 36. Everybody there? Okay. That is, I said A, that's one. Sorry. That's number one. All right, now number two. When is the trailer at rest? When is the trailer at rest? All right, here's a question for you. What's got to happen for a tobacco trailer, a ball, a particle, a big fat ex-football coach, whatever, to be at rest? One thing and one thing only. What is that? Velocity is 0. I don't give a flying rip what happens to acceleration. I don't care about position. If I'm looking for when something is at rest, then I'm going to set what, y'all? The velocity equal to 0. This is similar to the problem that we had earlier. Right now, so I'm going to factor out the 3. Don't let me mess up. And do you get t minus 2, t minus 10? Okay, times 3. All right, so now I got 3 numbers multiplied to be 0. So how can that happen? The only way that can happen is if one of them is going to be 0 and 3 is never 0. And so t has to be either 2 or 10. Good? Everybody good? All right. Now, number 3. When is the trailer moving right? When is the trailer moving to the right? Right now, think about this in the context of the problem. When was the trailer moving to the right? And by the way, Danny started the problem. I think I said, but let me just really make sure we're clear on this. Danny started the problem at the time that Uncle Everett lost the trailer and I jumped out in front of it. Okay? That's when the problem started. So in the context of the problem, when is the trailer moving to the right? Just in general, it's when the velocity is positive, right? How about how about in the context of the problem? When is the trailer moving to the right? When I'm trying to stop it, that's right. And then also,
When Wayne starts pushing back. After he stopped.
after Wayne stopped, right? After Wayne stopped. Okay, so we don't have to know all that to figure that. Now, we can do a split line with velocity. And I'm going to put the endpoints where, does this have endpoints? 0 and what? 15. All right, this is a split line graph, a sign chart, whatever, for velocity. We've already talked about how we're going to do this, whatever. You can take a test value, you can put it into factors if you're careful, or you can put it into velocity. Okay? How about this, y'all?
It's right on the side, the podium.
It's too low here?
Yeah.
I sure will. All right. The problem does not start until t is 0. All right? And it ends at 15. But think about this now. In the privacy of your paper, suppose it doesn't have those endpoints. And just suppose the domain for the velocity is all real numbers. Now, will that change these zeros at all? No. I say all that to ask you this. Could I use 0 as one of my test values? Yes, I could. All right? And if I let t be 0 here or in the factors, whatever, I get what? Positive. Okay? From 2 to 10, pick some value, put it in the factors, or put it into the velocity. That's safer. Then, let's see, let's put it in here. I'm going to make it hard. Put 3 in there. 3 squared, now 27. 27 plus 60, that's not going to be as big as 36 times 3. That's going to be the negative number. So this is negative, correct?
Yes.
All right. Now, once again, after 10, in the context of this problem, it really ends at 15, but could I put 100,000 million krillon in there and get the same answer? Yes. And if you do that into the velocity, really huge number, what happens? You can see that that's going to make all of this insignificant, and that's going to be positive. Good? So now, are we ready to answer the question, what is the question? When is the trailer moving to the right? I think we are, okay? What is that? From 0 to 2, 10 to 15. And if you don't mind, we're not going to discuss parentheses, brackets, all that stuff. Not going to worry about that. All right, if you want to do it differently, that's fine. And that's more of a philosophical discussion than a calculus discussion, in my mind. All right, look at 4. Number 4. When is the force on the trailer to the right? Now, time out. Before we do this problem, please think about this. In the context of the problem, when is the force to the right? Force on the trailer. When the force on the trailer is to the right.
When it was dropped, when it kept going.
No, it's negative.
When Wayne shut off.
Good discussion. Really good discussion. Let me ask you this question. What is it that applied a force to the right? What creature, what situation, what was it that applied the force to the right? Wayne. All right, so our answer here, when is the force to the right, is the whole time that what? Wayne is pushing. Now, remember the story. Now, there's only, we're not going to talk about the force due to friction. Just forget about that, okay? We're trying to overcome that, so that's play like that's not part of it. This is it's really slick road. Woo! That lane is really slick and have really good wheels on that trailer. All right, so there's not much friction. So the only two forces were those two crazy pre-teenagers, right? One was me, who tried to be the hero, and then Wayne. So,
I have a question.
okay, a lot of questions.
When the trailer got off of the truck or whatever, the resultant force should have been going that way for it to run away.
Say it real loud, I'm sorry.
When the trailer got off the truck, like your uncle's truck.
Well, now, like it never got off the, we're going to say that lane is the track, and it never got off the track.
Until
Like
the truck, the
The
tractor.
truck, I'm sorry, the tractor, yes,
Yeah.
my bad.
When it got off the vehicle, it was headed to the right.
Correct.
It jumped in front of it.
Yes,
So wasn't the resultant force on it in that direction because it was going that way?
ooh, that's what I do, crazy Wayne problem. The answer to your great question is, no ma'am. After that trailer came loose from the tractor and the problem started, the only force on that trailer happened to be scrawny little Kenny right when it first came loose, and that force happened to be which direction? To the left. Okay?
Can I ask one more question? So if we started the problem, if you had started recording prior to you stopping it, because you said once you jumped out in front, so you're saying there's no force even before you jump in front of it going to the right?
Well, let me take a little bit exception to your question here now. He started the problem when I jumped out in front of it, but it took me a little while to stop it.
Okay,
So
there
remember
was no
now,
force going to the right.
remember the trailer ran over me. Okay? And yes, woo, this is why I do this problem. So the answer to your question is the only force on that trailer as it is pushing me in that direction, the trailer is running over me. The only force on that trailer was provided by me in that direction. Got it?
Your question, you were asking about to the right. That's why you-
Yes. Okay, so are we good? Keep asking these questions. Keep asking these questions. Keep asking these questions. Because your young'uns are going to ask these questions. All right? Now, number 4. So when is the force to the right? Force has everything to do with what? And notice in parentheses I've got what? Acceleration. If we're thinking force, I think young'uns can hold on to force. I think it's hard for kids to say, when is something accelerating to the right? That's hard. They can get when is the force to the right. The force is to the right when I'm migrating, push it to the right. The force is to the left when what? When Wayne is pushing it to the left. Okay? All right. So now, in calculus class, we got to look at acceleration. So to find out when the acceleration is to the right, I'm going to set the acceleration equal to 0. And you'll see that t is equal to 6, correct? The only time. I'll do a split line graph for this. Let's label it A of t. Look at acceleration. Put 1 in here into the acceleration, and you can see, lo and behold, from 0 until what? 6. The acceleration, the force is what direction? To the left. And then after 6, what is the acceleration? It is what? To the right. So, in the context of the problem, what huge event happen at 6 seconds?
He had got it stopped and driven again. Right?
You stopped pushing on that
pushing,
button.
he was fixing to start pushing the force on it anymore.
Well, at 6 is like no elapsed time, right? So what, you got it, Joe, tell us, what happened at T is equal to 6?
So Wayne started to
He
push
got
and he
hit
stopped
under.
pushing.
Wayne started pushing and I stopped pushing. Okay? Y'all see that? Gosh, what a great problem for us. Do we see that? At 6 seconds. So I was pushing in only one direction. What direction? To the left. And I pushed it to the left for how long? For 6 seconds. After 6 seconds, Wayne started pushing. He pushed from 6 seconds until what? It fell into the ribbon. Okay, got it? All right, are we good? Or stay with us because there's still some events happening that's going to be interesting here, I think. All right, so 5 is a lot like 6. You know, when is the acceleration to the, what does it say?
What is the truth?
No, 5. What is the acceleration to the left? All right, acceleration to the left from, oh, did I answer 4? Nope. All right, acceleration, and number 4 is acceleration to the what? Number 4, to the right.
To the right.
All right, that is from what? 6 to 15. Number 5. That is acceleration to the left. And that is what? 0 to 6. Everybody get it? Everybody get it? Now, number 6. Number 6 is number 6 and 7. Ooh-wee is the main reason. Is the main reason I do the crazy Wayne problem in calculus class. It is number 6. When is the trailer slowing down? All right. Now, in the context of the problem, don't do the calculus yet. Some of you probably have already done it. But in the context of the problem, when is the trailer slowing down? The first time, if there are more than one time. When is the trailer? When I'm trying to stop. Okay, got it? When I'm trying to stop it, is I'm slowing it down the whole time. Is that the only time that the trailer is slowing down? When Wayne is trying to stop. Got it? Can we answer those two without the calculus?
Yeah.
Think we can? Are you let everybody have a few seconds. Think about this. When is the trailer slowing down? When is the trailer slowing down? All right, so slowing down from what to what? 0 to 2. Everybody agrees? Is that what you thought? And then from 6 to 10. Is everybody good with that? Please ask me. Please ask me. Please ask me. All right, let's do 7. In 7, when is it's worded just a little differently, right? When is the trailer's speed increasing? So what's another way of saying that? When is the trailer speeding up? When is the trailer speeding up? So speeding up. Now, in the context of the problem, or thinking about the story, can you tell me the times when the trailer is speeding up? I mean, it's staring us in the face when we see this, right? All right, so make sure you're thinking about what is happening to the trailer when this is happening. All right, so first time it's speeding up is from 2 to what? 6. The next time it is speeding up is from 10 to 15. Good? Any questions? Y'all got that? You feel really good about that. Feel really good about that. Okay. Now, with the kids, I'm going to do this, oh my stars, and I want them to get this answer before I show them what I'm about to show you. And I bet all of you know this. There is such an easy way to do these two problems, okay? But I want us to understand it. I want kids to understand it. So at this point, I would tell them, hey, just in general, what's happening? In general, what's happening in this story for the trailer to slow down? What's happening? Slows down 2 times. So what's happening both times the trailer is slowing down? What's actually happening?
Somebody's pushing from the opposite direction that it's moving.
Somebody is pushing in the opposite direction that the trailer is moving. Right? You got that? So to begin with, the trailer is traveling in what direction? To the right. And what am I doing? I'm pushing it to the left. Correct? So with that, what's going to happen? The trailer will slow down. Now the other situation, when else did it slow down? I really got it going pretty good. And then what? Wayne jumped out in front of it. I quit pushing. And now the trailer is traveling what? That direction, but Wayne is pushing it in that direction. Okay? Got it?